Hello, Bio 20, and welcome to our fourth video on the mechanics of breathing. This is lesson 2. We're going to be talking about how we breathe and measuring. So our goals today, our learning intention, is I am learning the mechanism of breathing. So how we actually utilize the muscles within our diaphragm and our intercostal muscles to bring in oxygen and remove our carbon dioxide, as well as we're going to make a connection about how much air we can breathe in and out. So how you know you've learned this is one, by being able to explain the role of inhalation by explaining the movement of the diaphragm and the intercostal muscles, which way are they going? You will also have to say, I understand this lesson by saying, I can explain exhalation by again telling me how are the diaphragm and the intercostal muscles moving. We are going to be looking at something called a spirometer graph, in which case we are going to define a few key terms, such as tidal volume, vital capacity, inspiratory, and expiratory reserve volumes. In order to say you understand this lesson, you should be able to pick those out and define them. You're also going to, through an exploratory activity, you're going to connect what is called your estimated vital capacity, how much you should potentially be able to move in and out of your lungs, so big breath in, big breath out, but then actually think about how could it be different based on environmental or physiological factors. So is your estimated the same as your actual? Why or why not? You're also going to look at a spirometer graph or spirometry graph and talk about how much air is being moved at different stages. So looking at tidal volume versus inspiratory and so forth. So all of these things will say to you, yes, I understood the lesson that was occurring. So let's start with the mechanics of breathing. So we know, based off of a few lessons ago, that air doesn't just magically flow into our lungs. It's all about pressure. Pressure outside has to be much greater than pressure inside. So when the pressure on the outside is greater, oxygen will move into our lungs. But here's where it gets really important. If your lungs didn't have space to move, you wouldn't be able to bring in a lot of air. So air doesn't just flow in and out of the lungs. What it does is it utilizes pressure, but it also uses two muscular structures called the diaphragm and the rib muscles or the intercostal muscles and the air pressure to help move air in and out of your lungs. What is the diaphragm? Well, you can see from my little GIF on the side there, the diaphragm is actually this dome-shaped muscle layer that separates your thoracic cavity, which is essentially your rib cage, from your abdominal cavity, which is essentially where your stomach is. Along your ribs are your rib muscles or your intercostal muscles. They're found between each one and along the ventral side. So if we were to look here, they would be in between each of these and along back here, okay? So those are the two muscles that we're going to be focusing on today. So let's look at the mechanics of breathing in this picture. Now you're going to be doing something a little different in your notes. I'm just going to show you what it looks like from your textbook. So in your textbook, it's showing this picture for inhalation. It says the intercostal muscles contract, lifting the rib cage up and out. At the same time, the muscle contracts and pulls downwards. Okay, so what does that mean? Here's my diaphragm. In order to create space in my thoracic cavity, the area where my lungs are, I need to create that space. So I need to move this muscle out of the way by pulling it down. So it contracts, it pulls down. But at the same time, you have to remember your ribs are covering your lungs. It's a protection mechanism. They're there to protect your lungs. Your lungs are soft. You don't want to have anybody getting access to them, right? So you don't want to have nothing there to protect it. They're kind of like if you play a sport, they're the protective gear of your lungs, all right? But again, in order for our lungs to be able to get bigger, these also have to move. So your rib cage actually physically lifts up and the intercostal muscles contract and help that do that. So if you take a deep breath in, you'll notice your chest rises up, and that's because you're physically moving your rib cage as your lungs inflate. Now, as I exhale, all right, the opposite process is happening. Now, I don't need that room in my thoracic cavity for my lungs. I can actually get back that space. So the diaphragm is going to relax and push up, which kind of think of it as pushing the air out, all right? And your rib cage is going to relax and drop back down. So if you sit and take a deep breath in, blow it out, you will feel the change in your rib cage. It goes up and then it comes back down. So that's the mechanisms of breathing. How do our muscles interact to bring in air and remove air? Now, to make it a little easier, we're going to draw it on this picture. So this is what you have in your notes. So we're going to draw and represent the movement of the rib and the diaphragm right here. So on the first picture, inhalation, if it's not labeled inhalation, please do. You're going to draw arrows that show the movement of the diaphragm, which is the big arrow on the bottom, and then the movement of the intercostal muscles, which are the little arrows on the side. Okay, so contract, that should say contract, not contact, but contract, the diaphragm moves down, and the rib muscles move, pull the ribs up and out. So they're contracting, okay? On the other side, we have exhalation. If your picture is not labeled as exhalation, please do. On this side, we have relaxing. So when it relaxes, the diaphragm moves up and your rib muscles relax and allow your ribs to go back to the normal position. So inhaling and exhaling has a large portion to do with how your ribs and your diaphragm move. So now we talked about how you bring air in through pressure, how it's exchanged into your body for internal and external respiration, how muscles help you give space to bring in air. But now we need to talk about how do we know how much air we move? And that is respiratory volume. So the picture you see at the top is a typical spirograph or done with a spirometer. Now you'll get a chance to see a video on how a spirometer works, but for now we're just going to talk about the theory behind it. So what we're going to start with is looking at this graph. You have to fill in a few pieces of information. The first one is called tidal volume. So tidal volume is the amount of air that is inhaled and exhaled when you're just breathing normally. So as you're sitting here listening to this video, as you were watching a TV show, the air that you just naturally breathe in and out, in and out, in and out is known as your tidal volume. If we look at the graph, it's that section right there. All right, so it's just those little bumps right there. So again, they're the same because you're breathing in and out the same amount every time. The next portion is called the inspiratory reserve volume. So inspire, meaning inhaling, okay? This is the additional air you can take in beyond a regular breath. So when you're at the doctor's and they're listening to your chest and they say, take a deep breath in and you breathe in and you hold it, that's your inspiratory reserve. How much air can you bring into your lungs? And it's represented on the graph right there. So that's how much you can breathe in. Now, what I really want to point out is your inspiratory reserve volume is calculated by where you're taking your breath, so at 2,400, all the way up to about, we'll say this is probably like 5,800, okay? So your inspiratory reserve in milliliters would be just this increase right here, okay? It's not 5,800, okay? That's not how much you can take in one breath. It's just how much you can take in on this one space right here, okay? Expiratory reserve is now the air that you can force out of your lungs. So when you take a deep breath in and then they say blow out all your air and you let go all the air and you keep blowing out until you feel like you can't anymore, that's called your expiratory reserve volume. It's the additional air that's forced out of the lungs, not during a normal tidal breath. So if we look on the graph, again, it's right here. So we would say this is the drop from about here, okay? So at about 2,400 down to 1,200. So we can remove 1,200 milliliters of expiratory reserve, all right? That's the extra air you can move out. The big one, the one that we want to really focus in on, is called vital capacity. Now, vital capacity is now your total lung volume capacity, which essentially means the amount of gas you can move in and out by taking a deep breath in and a deep breath out, okay? So, or exhaling out. This is calculated by saying, okay, I have a tidal volume, an inspiratory volume, and an expiratory volume. So essentially, it's this entire graph right here. What is your vital capacity, okay? How I would look for vital capacity is I would go from the 1,200, which is my biggest expiratory breath, add in up to my tidal volume, which is now 1,200 to 29, okay? And then up to my 58. So whatever the difference is from 1,200 to about 58, 5,900. That is my vital capacity, my estimated vital capacity, we'll say. Now, as humans, we can estimate our vital capacity based on our height, our weight, and age. And what you're going to get the opportunity to do is find out your estimated vital capacity, and then you're going to actually see if what you can actually move is the same amount. Because you have to remember, although we can estimate and give an estimation, it's based off of the average. This is what everybody roughly is. But physiological factors and environmental factors play a role. For example, my kids have asthma. My vital capacity would be different than their vital capacity. Now, yes, they are children and have a different size of lungs, but if my daughter grew up to be my age that I am right now, my vital capacity and her vital capacity estimated would be the same on a chart. But if I blow into a balloon and she blew into a balloon, I potentially could have a better vital capacity because she has asthma, therefore cannot move as much oxygen out of her lungs, or sorry, carbon dioxide out of her lungs. That's a physiological factor that may have an effect. Environmental factors could be what's in the air that day, is there smog, pollution, those kinds of things, okay? It can also mean genetics. Okay, maybe there's a reason why you can't move out air. Okay, so vital capacity, we can estimate what it looks like, and then we can actually calculate it based on activities we do. Now, the very last thing I want to talk to you about in regards to this is called residual volume. We learned through the pig pluck demo that our lungs are mostly filled with air and are always holding on to air. Okay, now, if we didn't have that air in there, they would collapse. So the residual volume is the amount of gas that just hangs out in our lungs and in the passageways of our lungs after you've exhaled. So after you've blown all the air out, your lungs are still slightly inflated because you have this residual volume. This gas never leaves our respiratory system. And that is because if it did, the collapsing of our bronchioles and our lungs would occur because we need that little bit of air to keep it inflated. This gas has no value for us. It's not filled with oxygen. It's not filled with carbon dioxide. It's just there, okay, holding space inside our lungs. So on the graph, you'll notice it's this blank space underneath. If you've ever been swinging on the monkey bars, okay, you go, 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 and then you fall off, you fall flat on your back, and you get the air knocked out of you, you feel like you can't breathe at all. And that's because you've literally knocked out all of your respiratory reserve volume and probably a little bit of that residual volume that's keeping your lungs open. Now, when you knock that out, okay, it's going to feel really hard to take a deep breath in. Now, when you finally kind of get bearings back, then you can take that deep breath back in and you feel like you can breathe again. So residual volume is just that extra air that sits there. So if you have any questions, please let me know.